Hello. So okay, so Xiaofen's here. He's the leader of the Milvus project, and he's gonna talk about Milvus 2.0 GA release and the roadmap for Milvus 2.1. And Xiaofen, ready?
Okay. Hey guys. So I probably want to record the screen so we can share the video to the whole group.
Yes, I think I'm recording in progress. Yeah.
So before I just want to talk about the plans for Milvus 2.0. There are a couple of issues we want to talk about for the GA release. Okay, so the whole community and also the contributors are still remain focused on the GA release. There was a broad consensus that we want to keep working on the stability issues and freeze all of the feature development before the GA release. So there are a couple of action items. So for all the contributors, please sign up and check all the GitHub issues assigned to you. Make sure that all the bugs under your name should be in the GA release, also the master branch, or mark it at 2.0 backlog. Okay, so for all the maintainers, please go through all the GitHub issues. When you have time, you should also seek assignees to solve all those issues if you think those issues should be fixed before the GA version. Okay, so for all the Milvus users, please keep tracking of the latest daily release. Make sure that all the issues should already be solved. Maybe some of the issues you are looking into are already be solved. Okay. Sure. So there are still a couple of issues we probably want to help before 2.0 GA. The first one is some pulsar related stability issues. We'll see some of the users, they want to upgrade pulsar versions because of log4j security issues. We tried to upgrade to 2.7.4, I guess. But we saw kind of the stability issues for the newer pulsar versions. So we'll still keep investigating on which pulsar version will be the dependency of Milvus 2.0. Okay, so we also see a couple of the panic issues under concurrent search. So I think a couple of guys still investigate on that, but if you have any progress, please update on the GitHub issues. Okay. So the third issue is some weird performance bottlenecks, because we see that under smaller data sets, the current performance is 200 milliseconds or 300 milliseconds. But after we change the consistency tab, for now it's 16, 17 milliseconds, but I guess we could keep improvement and make it to less than 10 milliseconds in the later versions. Okay. So next part I'm gonna do share my screen, and the topic will be some 2.1 points for the Milvus. Okay. Star, can you see my screen?
Yep, we can.
Okay, cool. So the first part will be the 2.0 timeline. So since we are super close to 2.0 GA versions, the current release date will be I think this Saturday. Okay, so then we're trying to planning for the next big release, which is 2.0. So our targeting date will be on April, I think the last day of April. Before the 2.1 release, we probably need to freeze 1 month before the targeting date, and we'll have maybe 1 or 2 RC versions, but definitely not 2.0. We have 8 RC versions. So I guess we're going to have one RC versions after the code freeze, and we think we solve all the bugs. So users could do more tests on the Milvus 2.1 branch. Okay. So people may be like interested about what will be inside 2.1. We talked to like 6 or 7 customers, and from their feedbacks, those users are looking for like, especially for the performance part and for some kind of functionalities. So we just list all the urgent feedbacks. Okay, so for the functionality part, we'll be focused on those like 4 different categories. Okay, so the first one will be the string support. Okay, so we talk about the string support even before the Milvus 2.0 RC1 comes, right? But due to some lack of manpower, we didn't finish these features. So I thought this is probably the right time we can do the string support part. We already have a Milvus enhancement plan, and I thought Xige will take the responsibility to do these features. Okay, so if you're also like interested in the string support, you can probably like leave some message under the Milvus enhancement plan, and maybe talk to him under Slack or using GitHub issues. Okay, so next features will be time to leave. Okay, so since Milvus is a database, like user ingestion a lot of data, and some of the data they may have a time, like after the certain time they want to expire all the data and purge it from MinIO and probably the Pulsar devices. So we are trying to support automatically purge all those data based on the timestamp. Okay, so I think engineers from line, they are trying to contribute to Milvus about this feature. Okay, so the feature will be separated into several parts. So the first parts, they're just going to go through all the data during compaction and remove all the data like older than certain kind of threshold. Okay, so for the second part, I thought they're going to like support config time to leave based on per collection, or maybe even based on per partition. Okay, so for the third part, what we'll do is we're going to do like remove all the expired data during the read pass. Okay, so because for now we're just doing a background removal of all the outdated data. But if user want to like search out those data, we're going to change the search path. We'll still keep using the bit set to mark all the deleted data, so those data won't be shown in the search path. Okay. The third features are going to be multi-memory replicas, just as the graph shows. So currently we only have one query stream. So each cache will be separated to different segments. The proxy sends the result into the query stream, and all of the query node which holds those segments will receive the request and do the response for their segments. This looks fine, but there is an issue that if you want to do like millions of the queries, one replica may not be enough. Let's say if we have only like 1 million data, it should be like in only 1 or 2 segments. But we had like 100 of query nodes, then those query nodes will not be assigned to a segment. Okay, to solve these issues, we're going to have like multi-memory replicas. So those replicas will be like subscribed to the same log stream, so they have exactly the same data. So the proxy is going to be round robin query all those different query streams. So we could like expand our throughput based on how many physical resources you have. Okay, Another like good points for the multi-replica will be it will solve the recovery issues. As you may know that once the query node down, the Milvus need to like reload the data from the disk, which is kind of slow. It takes around like a couple of minutes and even maybe 10 minutes if you have a lot of data per node. So once you have multi-replicas, then what we could do is we just change all the traffic to the other replicas. Okay, so the failure recovery speed should be like faster. Okay, so once we have the multi-replica design, another thing we could do is speculative execution. So speculative execution is just a optimization. So it kind of used for computer systems to perform some tasks that you may not need. From our side, what we do is we can send one request to replica 1, and it didn't. If it didn't respond for like a couple of seconds, we just send another request to segment 2 and replica 2 and wait for result to come back. Like no matter which replica comes back earlier, we'll just take the result and send back to the SDK. Okay, so with speculative execution, our availability should be much better. And also, like we've seen a couple of like users that what they are trying to do is just to return partial result. Let's say if I have hundreds of the segments, maybe like 10 of the segments are on a failed query node and they can't do response. What we can do is we can just return partial of the result for better availability, even though like your maybe your accuracy will be hurt. Like in some of the user cases, like availability should be more important. So I guess speculative execution and partial result returning will be help us on the availability part. Okay. So the last part would be the account and password. Okay, so we're going to support users and password for the security reasons, and even more, we're going to support all the ACL, like the RBAC users who are going to have different authorities such as read, write, and admin. Okay, so those about the features. So for the architecture change, we're going to have those 3 following issues. The first one is plugging message storage. So for now, Milvus just support Pulsar, but we'll see a lot of users, they have their own Kafka clusters, or maybe RockSMQ clusters, or maybe Kinesis clusters. Okay, so what we're trying to do is we're going to make our message storage a plugin, so users can pick their own message storage, especially like I saw a lot of users are looking for Kafka support. Okay. And another big change was we're going to have another component which we call it as log node. So for now, all the proxies on the right path, all the proxies will just be written into all the topics, which brings us a lot of trouble because we have this time tick mechanism. So all the proxies, they'll have to like send their time tick stats to the root cord, and the root cord we're going to do a merge and find all those lag behind time ticks and then send back to the topics, right? This brings us trouble because it makes the system a lot of like kind of complex, and also we don't have those kind of single point on the right path, so we can do a lot of features such as find segment IDs for each primary key, or do this primary key deduplication things. Okay, so we're trying to add one log node. So each channel or each topic, we're going to only be handled by one log node. So all the proxy, if you're written to those channels, you're just going to talk to the log node and use the log node to send those data into the topic. Okay, so then the log node will be the single point for those topics and it can do a lot of different things, such as it can issue a time tick rather than use the root card. Okay, so it can assign those segment IDs because only I am writing into the segment, so I have the control for the whole flush steps. Okay, I don't need to like communicate between proxy, data card, root card. That kind of annoy. Okay, and for the further development, we're going to have a KV index or log index on top of the logs. Okay, so using the log index, we're going to support find PKE duplications, like find all the mappings between PKE and segment. Okay, we'll have like more detailed MEP, and we're going to discuss on the next tech meeting about the infra change. Okay, so the third architecture change will be move Nowhere out of Milvus as an independent open source project. Okay, so as we all know, Nowhere is the core engine of Milvus, and it contains a lot of different vector search algorithms such as FAST and HNW. Okay, so we want to move Nowhere out of the project because it can like develop independently and have their own unit test, and also for the CI test. Okay, for Milvus, it's kind of like a plugin, so we could have like more different choice rather than only support Nowhere itself. Okay, and move Nowhere outside will also like give us great convenience because Nowhere is written in C++, and the whole Milvus project will be in Go, and the development part will be it's kind of easier. Okay. Okay, so we're also like working on the performance boosting part for Milvus 2.1. Okay, so the goal will be like a 10 milliseconds E2E latency on the smaller data sets. It's kind of like a few millions of data, and we also have a large data cases for like 100 million of data. And support like 10,000 query per second. Okay, so that is going to be like show the scalability for the Milvus 2.0. Okay, the first thing we're going to offer is a performance benchmark. So I think some of the maintainers and contributors are already working on these issues. Okay, so the next part we're going to do move some of the bottlenecks, because we never do the profiling for the end-to-end pass, and we're going to do it in the next 1 or 2 months. Okay. Also, we'll kind of focus on the standalone mode because most of the users, they just have a smaller data sets, and the standalone should be pretty much good for them. So one thing we want to do is we can change the gRPC implementation between each node to a memory RPC. Okay, so it should take less time for the overall communication time. Okay, another thing like 1.1 Milvus 1.1 has been done is the request combination. We just merge multiple enqueue small enqueue requests into a large one, so the whole system query the throughput will be increased. Okay, but to be noticed that there will be a little bit latency loss. So I think request combination will be kind of used for only those offline scenarios. Okay. Last part will be easy of use. First of all, we're going to support Milvus standalone as a single process. Okay, we've already moved the support for etcd. So for now, we can use embedded etcd. On the next part, Qingxiang, we're going to talk about how we can remove min.io under standalone mode. Okay, then for Milvus standalone, there will be only one process. Okay, so and we'll also like support Milvus as a Python embedded library. So since it's already a one process server, we just add a Python on top of those standalone mode. So user can just do pip install and install Milvus under their laptop and run all the tests. I think that will help all those data scientists to do those experiments. Okay. Third part will be development and run Milvus on Mac laptop and on servers. Okay. Because before 2.0 GA, Milvus can only be run on CentOS and Ubuntu, and I thought that'd be like really inconvenient, especially for the MacBook users. Okay, so we also have a session about how to run Milvus on Mac, and I think Ring is going to talk more about this. Okay, last part will be C++ and RESTful SDKs. Okay, for Milvus 2.0, we already supported Java, Python, Go, and Node.js. I thought the C++ and RESTful will be the last part we're going to support for the multi-language SDKs. Okay, cool. So beside the codes, we're going to also like do a lot of the different stuff on the community improvements. Okay, since we are an open source project, like all the guys, they want to like put part of the code inside. So I thought the code review was going to be really important. So for all the maintainers, we're going to do like spend more time on the code review. We also like set different standards. What we're trying to do, the first step is for all the logs, we'll have the standard, and we're trying to like refactoring all the logs in the Milvus project. So make sure that we can find bugs easier, and also if you put into the production, you can like combine Milvus together with ELK or maybe Loki for the better management. Okay, so we also like set up our membership. That should be very important. For now, Milvus have like five maintainers. But we should have like even more committers, because we'll see that we have a lot of work to do in the community, and we have like bunch of code per day that as our a little bit like overloaded. So if you're interested to be a part of the Milvus community, like please contact me. We probably need to set up some threshold, like your code contributions, your review contributions, but we welcome like everyone interested to join us. Okay. So there will be also a mentorship part. So for each one, if you're interested in contribute to Milvus, okay, so we'll currently have this mentorship program. So we'll have one committer or maintainer. We're gonna do like give you some support about the overall architecture, about the code style, like give more advices on your code. If you're interested, you can talk to Suda, and he is the owner of the mentorship program. Okay, so last part will be technical documentations. So looking for volunteers to refine our technical documentations. The process will take like 1 month. We just start after the 2.0 GA, and I think what we're going to do is we're going to have a long list about all those components and all those features. Okay, so if you're interested in certain mechanism or components, you can just leave a message on the document. I'll just share the document in the conference later. Okay, so I think you can take the owner, you can go through all the code and write some technical documentations to share. Okay, cool. That's pretty much for today. Any questions?
If you have any question, now would be the best time to ask.
No questions?
Mm-hmm.
Yeah, feel free to contact me if you have any questions on Slack or GitHub. Okay.
Yeah, just send us a message on the Slack channel, the user channel, and we're gonna come grab you. And a little more for the contribution to the Milvus project. Not only you can contribute code, and if you know multiple languages, we also need people to. We also need to translate the Milvus doc to various other languages, and that would be very helpful too. And yeah, and the Milvus mentorship program is running. So if you are willing to, if you have the willingness to contribute, send a message to the Slack channel, to the Slack Milvus users channel, and I'm gonna come grab you. All right. And the contribution on the technical side, we're gonna have more detailed documentation about how to set up your environment and how to debug, and some of the best practices. And we're also going to have a video that demonstrate the whole process, so it's more transparent, it's more clear. And yep. And if there is no question for Luan, okay, last chance. Any question? No. Okay, so I will hand over the mic to Yuchen, and he's going to kind of give a presentation about the progress of supporting Milvus 2.0 on Mac. And Yuchen, there you go. Ready?
Yeah, by the way, I thought it's a good, interesting topic to set up a bunch of the videos about how to contribute to Milvus. I thought we should do this.
Yeah. That's ideal. We talked to some users from eBay, and they said this is going to be like tremendously helpful. So I think it's a really good idea.
Yeah, especially when we support building Milvus on top of Mac laptop.
Yeah.
Yuchen, are you ready?
Wait a sec. I think I need to make him co-host.
Okay. You guys can see this, right?
Sure.
Yeah. Right. Hey guys, good morning / good evening. My name is Yuchen, and I'm going to give a talk about little bit about building Milvus on macOS machines. And this is something we have done quite recently. There with the help of the 3 excellent contributors. So for a very long time, you guys might know that Milvus is only supported on Linux machines. This is because we, like most of our contributors, are like either Ubuntu or CentOS users. But we know there are great amounts of MacBook users over there, and you guys might wonder that does the community even care about the macOS users? Well, the answer is we do. We really care about you guys. We know that there is a large population of MacBook users, like macOS users around the world. And it'll be awesome if these guys can also use to build and run Milvus on their own machines as well. Well, right now, Milvus is only supported on Linux machines, which means that you can only run Milvus within a container if you're using a macOS machine. Well, it's not too bad, but there's more we can do, right? Oh, by the way, for those of you guys who use the most recent Apple Silicon, aka the Mac M1 machines, you might have some trouble starting a Docker container, starting a Milvus Docker container with your Apple Silicon machine. The good news is that we have released a new Milvus images after release, after the 2.0 RC8. So any images after this version can successfully run on Apple Silicon machines as well. But simply running Milvus within Docker container is not a perfect solution. So here's some more. So long story short, Milvus is now buildable and runnable on Linux distributions. You can use my machine. Linux distributions and macOS machines with the Intel chips and the macOS machines with the Apple Silicon chips, aka the Mac M1 machines. So that's good news, right? So when and where can I try this? So this big change will be released right after the GA. So you guys know that we are doing this magnificent 2.0 like GA thing, right? So you can just try our Mac version right after GA. And the GA is the, as Xiaofan mentioned, is pretty soon, right? And for those of you guys who really cannot wait for the GA, there's some branches you can try. Yeah. But beware that we're doing some, it has some external dependencies, so it might break from time to time, but that's how things work, right? So what? All right. So how do I? So if I have a MacBook or if I'm a Mac OS users, how do I, play with Milvus? So the answer is exactly the same as running on like Linux machines. So just like exactly the same steps. First, you clone the Milvus project. You run the script to install the third-party dependencies. Of course, we will, according to your system and your system architecture, we will install different dependencies. And then you make. And hopefully, everything should pass, and you will have your Milvus target. And that's it. And now you can test with it. We have this, so on our README, you can find our unit test and coverage test. So all of these tests are also runnable, or testable on Mac Silicon machines, or also including the Intel Mac machines as well. So it's exactly the same as the Linux machines, exactly the same what you do on Ubuntu machines, Linux machines. But there's only one thing I need to mention is that so to run the unit test, you have to start a local Milvus environment. And there's a part in this environment, which is Pulsar. And as it turns out, the official Pulsar image doesn't work on Apple M1 machines, the Mac M1 machines. It will just crash. So what we did is like we built a whole new image, a runnable Pulsar version just for Milvus. And you can, but you have to do something different, is that you have to Docker compose with a different YAML file if you're using a Mac M1 machine. Okay, next we'll talk a little bit about the Milvus and Rearchitecture thing. This is something we have done in the meanwhile when we do the MacOS Support project. And you can on this on the Confluence, you can find this proposal by our senior contributor Jamie about how we have this plan about support debugging and running on Mac. And in this proposal, we have this. He talked a little bit about this Rearchitecture thing. So basically, if you can see this picture, Milvus has a core engine part, which is called Nowhere. And Nowhere has all the distant calculating algorithms or like indexing things. As you can see from this graph, like we have these really messy dependencies. And it seems like we have a lot of dependencies on face. And, and the Milvus itself, the distributed layer has dependencies on like Nowhere and on face itself, and it's really kind of mangled. So while we're doing this Mac support thing, we also did this Rearchitecture thing. Is the two biggest thing we did is the first that we make a unified interface of Nowhere, and the second thing is that we moved Nowhere to a new OSS project, as mentioned by Xiaofan in the previous talk. If you guys are interested, you can read this proposal. I'm not gonna talk too much about the details here. So you guys might wonder is that another question is, will the Mac version of Milvus be just as good as the Linux version? And the answer is yes and no. No, it's because it's not just as good as the Linux version, because we have temporarily disabled most of the indexing things on Mac, because we have a lot of libraries that has a lot of this instruction code related stuff, and those things just don't work on Mac, and of course not on Mac M1 machines, because the different CPU architecture. So we have temporarily disabled them, but so right now only the index flat is supported. So basically, you can only use brute force, but you can still do things, right? That's not the end of the story, because we within like 1 or 2 or 2 or 3 minor versions will be fully support the missing parts. So what we'll do is like we will first upgrade our Nowhere. And so we will make our core index libraries to support the algorithms that we should support. And the next thing is that we will upgrade our face to 1.7 or 1.7 some version, because we're doing this because we haven't upgraded face for a very long time. And there's a lot of good features that new versions of face are providing, like range search, which is like, and a lot of other really good stuff that's quite like a lot of our users are fond of. Yeah, so we will also upgrading face to 1.7 stuff. There are a lot of tricky things if you're using Mac Silicon machines. So I will not talk all about it. Just one last thing I need to mention, especially if you just got your new Apple Silicon machine. So on Apple Silicon, for example, Homebrew installs file into a whole new different folder. So it will now install stuff under /opt/homebrew instead of /user/local. So what you have to, the consequence is that you have to do a whole bunch of soft links to make things work, to make your libraries findable. Yeah, but don't worry about this. We have taken everything for you in the scripts. There are a lot of, as I mentioned, there are a lot of tricky things with Mac M1 machines and also other Intel Mac machines as well. But don't worry about those. We have taken everything for you. So what you need just to do is just to install dependencies, make and run unit tests. Yeah, so that's pretty much it about the Mac part. Thanks, guys.
Okay. Okay, so is there, sorry for the echo. So is there any question for you, Chen? Now would be a good time to ask.
Questions? What is the like next step? Are we going to support all kinds of index tab for the laptop and maybe ARMs?
Sorry, we just muted our KK.
Oh, okay. Yeah. Just quick questions. What is the next step? Are we going to support more index tabs on the Mac laptop?
Yeah, well, I think we're doing this pretty. It should be done pretty soon, like within like maybe 2 minor versions. So I think we can finish this with maybe before the big 2.0 GA release, hopefully.
Cool. Because like for now, like the path for the setup for the developers will be like super long. You're gonna have a Docker like set up the VS Code to do the remote debug. So once we have these features, I thought it will be like pretty clear for the all the developers to join the community.
Yeah,
cool.
Pretty cool. Yeah.
Good job.
Okay, so I'm gonna move the meeting to the next section, and Milvus standalone will support local storage in the future, and that is in progress. And Qingxiang, one of the Milvus project engineer, is gonna give a introduction of that. So Qingxiang, ready?
Okay, I'm ready. Okay, I'm Qingxiang, and I'm sharing the MVP of make the storage engine configurable. My sharing agenda is listed as follows. I will first I will introduce my motivation of this enhancement, and I will introduce the problems we faced. At last, the configurable storage engine design we will I will introduce at last. Okay, now enter the motivation. First, motivation, we found that standalone relies on MIO. However, this is actually not necessary. We found remove MIO dependence will have 3 benefits. The benefits we found there are more efficient reading and writing of persistent data, for it don't need network communication. If MIO and local storage media are the same, if your MIO is SID and this is HDD, this may be not correct. But if you both use SSD in MIO and disk, the disk reading and writing performance will be better. And the next benefit is reduce the impact of dependence component. For example, when you start standalone Milvus, if you have a dependency of MIO, the MIO crashes, your standalone Milvus will be unavailable, but the disk is always available. This will improve the standalone availability. The last motivation, the last benefit is the dependency injection. The dependency injection can be done with local storage which removing the dependency of main.io in unit test. Now our Milvus, now if we make unit test in Milvus, we need to start a main.io Docker, but it seems unreasonable for unit test. For unit test, shouldn't contain the functionality. Shouldn't contain the functionality of external components. And the next part is challenges. The first challenge we face is the main.io now is used as KB storage interface. KB storage interface, the return value is string type. However, the string type will suffer from CPU performance disaster and the memory usage disaster. For example, for current KB interface, now the key string return value is string. The implementation of main.io will obtain the byte array to string. For Go, converting byte array to string will make a copy of data in memory. This is disaster for performance and memory. Let's see an example. The test is a byte array. If we convert to string, this will make a copy. If the array of byte is too big, the performance will suffer the disaster. And next challenge is we shouldn't change the existing startup logic and related interface too much. And the storage engine should be configurable through Milvus.yum. It means that users can also choose to use main.io or others as storage when using standalone. For example, if your main.io uses SSD and your local storage is disk, you can configure this for better performance. And the last part is my design of configurable storage engine. For solving byte array to string copy, we redefine the interface implemented by main.io. All file storage need to implement this interface. The change is we rename the load to read and the return value from string type to byte array type. And there are three implementations: local chunk manager for local disk, and the main.io chunk manager is for main.io storage engine. And the vector chunk manager will depend on two chunk managers, one for vector cache and one for persistent data read. Now the vector chunk manager will read from main.io and cache in local storage. But you can define it for yourself. And for not change the existing startup logic and related interface, more generic factory instead of existing message factory will be used to build nodes. Factory, the original is message factory, but we change it to a generic factory. The factory will be like this. It contains message factory and storage chunk manager factory. And the next, according to the above, a chunk manager factory similar to message string is needed. Factory is added to generate chunk managers with different configurations. We can see we have added a chunk manager factory, and this chunk storage will define our persistent data storage. Okay, vector cache storage is for vector chunk manager. It will be a cache, and we make a options for the parents. If we define the chunk storage for string, if we use S3, it will implement S3 the storage as chunk manager. If we use MIO, it will implement the MIO storage chunk manager. And another part is chunk manager config is needed to generate different chunk manager with the same interface. This structure will have some latency. For example, local storage will not require parameters such as address and bucket name, but will be easier to reuse. The deploy in Milvus Technical will set the default storage engine for different deploy mode. The vector cache storage and chunk storage will be used to set what to use as the storage engine. In standalone, you can see this. The standalone you can choose chunk storage local, and vector cache storage and is local. And the default for distributed is chunk storage is MIO, and vector cache storage is local. In standalone model, chunk storage using local is more efficient choice. Of course, you can also choose MIO. However, if distributed version choose local storage, because the nodes are located in different machines, the data stored locally are inconsistent. Therefore, careful considerations should be given for when choosing a storage engine. And anything else, you can check in this MVP progress in F Data Foundation Conference and GitHub issues. You can comment on related GitHub issues or conference MVP 22, and you can email me for discussion. Thanks. Any questions?
I just have one question. Can you quickly go back to page 16? So for the distributed versions, why the vector? It's vector cache storage, right? So do we have configuration for the vector chunk storage?
Yes. The vector chunk storage is for vector data. Now we will read the data from MIO and deserialize and store it to local. And for next search, if the data exists in local storage, we will read from local, other than MIO.
Okay, so how do I disable the vector cache storage?
There are another configure. Okay. I will rename another configure. Now the configure is local storage enable. Okay, and I will add it to. I will move another configure to this. This will add an enable for this. Okay.
I would just suggest that we can have another implementation for vector cache storage to be known, which means you just disable the whole cache instance.
If we disable the vector cache storage, all data will be read from chunk storage.
Yeah, but I mean, if I don't have the local disk, I should just rely on the
MIO. Okay. So only use MIO. Okay.
And also, I think it's a switch case that based on like what kind of the chunk storage you're going to choose. Like like I thought, we should have S3 chunk storage and chunk manager and MIO chunk manager. Right?
Yes. So, you should have two implementations.
Okay, just kind of an implementation for the chunk.
Yes.
Okay. So what will be the difference between the vector chunk manager and the chunk manager?
Chunk manager is vector chunk manager is specific for vector data, and chunk manager is for vector chunk manager. It will contain serialized and deserialized, and it add vector cache storage for cache. So it is vector chunk manager also implements the chunk manager, but it have some advantages than some than the local chunk manager and the manual chunk manager.
Any other questions?
Yeah. Can you guys hear me?
Yeah.
Yeah. Okay. Thanks for the introduction. Question on backup and restore for snapshots. What is the best practice for taking snapshots and then restoring on local or Milano storage?
Okay, Star, anything else?
Okay. No, we couldn't hear you because I don't know why. Could you repeat what you were saying?
Oh, should I repeat the question?
Did you answer to that question? Like how to take snapshots and because we couldn't hear you. Okay, so for taking snapshots, so are you looking to kind of like back up your Milvus server, the data persistence?
Yeah.
Okay, so there's a functionality with called time travel, so you can search the collection, the state of the collection up to like 7 days before. You aware of that, or you want like a more persistent backup?
I guess it's more persistent
Okay.
backup
Okay.
on like a frozen storage.
Okay, so that we probably don't have that, and we need to wait for Xiaofan, wait for Luan to come back, and he's gonna answer this question. Give us a second.
Or if I
I'll
phrase
go
it
grab
a
him.
different way, if I need to, let's say we have a production environment, and then I want to carry something from production to staging environment for 7 days, and then work on those data. What is the best way to do it without snapshots?
Okay, so actually you're looking to kind of migrate the data from your staging to production. Is that what I'm?
The other way around, from production down to staging.
Oh, so could you repeat that? I couldn't hear that. I didn't.
So if I have like a couple million records from production, and I
Yes.
don't want to regenerate them on staging, I just like to take it from production and then carry over to staging.
Yeah, so that is actually you need it like a data migration tool, right? Is what you're looking for. Okay, so we have a Milvus DM project that
hello, this is Yera. Maybe I can answer this question.
Okay, go ahead.
Yeah. For now, Milvus does not have this kind of feature natively, but we are talking about this feature in 2.1 or 2.2, but this is still in design, so we didn't share that in the community yet. But if I think if the user has some requirements for that, we can discuss it in the community. Another reason that we are still in discussing for this feature is that we are thinking of implement this feature with some cloud service to help our users to back up their data into cloud to have a more safe level. So I understand this feature, but this is still in discussing, I think.
I see. Okay, I'll follow up on the community slide.
Yeah, you can. We can keep you updated in the community, and you can keep eyes on that. You can just join the Slack channel. We can discuss in that the channel.
Okay, all right, with that, thanks.
Yeah, so for the migration tool, we build one for Milvus 1, and because Milvus GA is yet to be released, and we want to wait until everything's stable, and we're gonna start working on that, and that's in the short future, and we have plans for that. So any other question? Okay, so yeah, so if you don't have any question now, everyone, so thank you. How can I join this community? I want to join mentorship program. I want to contribute Milvus. Okay, I think you sent a message in Slack, right? And I replied to you. And yeah, thank you for your willingness. And we need more people like you in our community. And then after I come grab you, we can talk about basically like what feature do you want in Milvus, and what do you want to work on, and kind of your skill set and your background, like what is a good size of a feature that is suitable for you to work on, or issue, and we can go from there. And if you need help in the progress, I will help you, and if something I cannot cover, and I'll grab one of the engineers to give you assistance. And we can talk about how to write an MEP, and all of the process in between. And yeah, so if you want to contribute, just basically send a message in the Slack channel, and I will come grab you. Okay, and we can take this offline. I'll DM you. So thank you everyone for joining. If you have any question in the future about Milvus, about basically anything related to machine learning, machine operations, we can talk in Slack. And so the next live event is the Milvus office hour for Asian Pacific, and that's, I think it's on the 24th, and we're gonna send an announcement in the Slack channel, so keep an eye on that. And 26th. Sorry, thank you, Kate. And okay, so thank you everyone for joining, and have a great day or great night.